In section 10.7, we want to start out with reminding ourselves how to find the area of a circle. Now, circumference, there were two circumference formulas, pi d and 2 pi r. Because remember that diameter equals 2 times a radius. That's why we can have two equations. One dealing with diameter, one dealing with radius. But the area of a circle does not have two formulas. It is only one formula, and it only deals with radius. So our area is going to equal pi r squared. A couple of things we need to talk about with that. Area equals pi r squared means something very specific. It means I want to take pi times the radius times the radius. That's what pi r squared means. And the reason I say that is because I occasionally have students who, when they go through and do this, for example, if I say that the radius is 2, I'll have students that want to come in here and say, all right, well, that means that my area is going to be pi times 2 squared, and so I'm going to grab my calculator and I'm going to take pi times 2 and get an answer, and then I'm going to take that answer times another 2. Okay? Or I'm going to take that answer and square it. Okay, you can't do that. You can't multiply pi times the radius and then square it, because it's only the r that's squared. It's only the radius that's squared. Okay? So be careful of that. You cannot do this. This is absolutely 100% wrong. Okay? So what would you do instead? Well, if the radius was 2, in my make-believe example up here, area equals pi times 2 squared. The 2 is being squared. Well, what's 2 squared? You got to remember PEMDAS. PEMDAS says that you do parentheses, then you do exponents before you do any multiplication or division or addition or subtraction. And so you have to calculate 2 squared first, which of course is 4. And so then 4 pi is the correct unit, or the correct answer in this particular problem. That's the exact answer, right? Okay. So only the r is squared in pi r squared. The other thing that I want to make sure that you understand is that when we're working with area, the unit of measure is no longer inches. It's no longer feet. It's no longer a distance. The unit of measure now is that unit squared. So square inches or square feet or square miles. Because I'm now trying to decide, rather than how many 1 foot measurements I can do going around as a distance, I'm now trying to find out how many 1 by 1 little squares can I fit inside this object. Okay, that is what area is calculating. How many little 1 by 1 squares can we fit inside this circle? Okay, and so we're doing everything in square units. So this circumference was measured in feet, but area is measured in square feet. Okay? And I will be taking off points for improper units. So you need to make sure that you know, am I dealing in feet as a distance or a length, or am I dealing in square feet as an area? All right? Questions, comments? Okay. Then let's try an example. We have the area of the circular region of a wrestling mat. So they give us the diameter there is 32 feet. All right, we need to find out the area. So what is my area formula for a circle? Area equals pi r squared. There's only one formula. And so if my diameter is 32, what's my radius? Yeah, my radius is going to be 16 feet. Okay? And so I'm going to take pi times 16 squared. And we're going to leave this as an exact answer, so we just got to plug into our calculator 16 squared, because I don't know that one off the top of my head. I probably should. 256 pi, and then our units here are going to be square feet. And by the way, writing it the way I did, that's an abbreviation. That's written in kind of math speak, okay? Don't say feet squared. It's called square feet. All right, even though we write it as the math abbreviation, the unit is actually square feet, square inches, square miles, okay? So please make sure you're saying it that way. Questions? No? Easy peasy? Okay, then why don't you guys try these two on your own? Ready, set, go. Okay, good. I'm seeing lots of good answers here. So what we should be doing first off, notice that both of these problems, they give us the diameter, not the radius. We have to have the radius. And so if the diameter is 8, our radius is 4. And in the second problem, if the diameter is 16, our radius is 8, right? So plugging in then, pi times 4 squared, we should have an area of 16 pi square feet. And in the last one there, area is going to be pi times 8 squared, and so our area should be 64 pi square centimeters. Please make sure you're giving units. Okay? Please make sure you're giving units. If there are no units given, then your answer for area would be 5 square units. Okay, you actually write out the word units and make it squared. Okay, we need to see units when we're talking area. All right, questions or comments? Area, easy peasy? I'm pretty sure you've seen this in previous math classes before. This is not the first time you've seen area of a circle. But what we're going to be doing new today is the area of what's called a sector. A sector is nothing more than a slice of pizza, okay? In fact, you could be the cool kid at the party if you give everybody slices of pizza and tell, oh, here, you have 14 square inches of pizza. Enjoy. Oh, here, you have 18 square inches of pizza. Enjoy. Yeah, that was always popular at parties. All right, so all we're doing is finding the area of a slice of pizza, all right? And just like arc length, this is just a fraction of the area. Arc length is just a fraction of the circumference, right? So this is done the exact same way. And just to prove that point, what if I have a circle that has an area of 20 square inches? Okay? Well then, if I come over here and draw this diameter and I say, all right, I want the area of that part of the circle. How much of the circle do I have? Half of it. So what's the area of that half? 10, because it's 1/2 of 20, which is 10 square inches. Just like we did with arc length. What if I come in here and say, all right, well, but what if this is a 90-degree angle and I want that part? How much do I have? What's the area of that? It's going to be 1/4 of 1/4 of what? What's the circle? 20. 1/4 of 20. Right. 1/4 of 20, which gives us 5 square inches. Why is it 1/4? Just the same reason as it was with arc length. It's 90 over 360, which reduces down to 1/4. Or the one in red was 180 over 360, which reduces down to 1/2. It's the exact same concept as arc length. And so, here is our formula for the area of a sector. Okay, and notice how they named the sector. Area of sector AOB. Okay, A and B are the end points of the arc. O is then the center of the circle. Okay, so they're going to name it AOB. But the area of that sector is going to be the measure of the arc over 360 times area of the circle, pi r squared. Okay? So let's try first one here. So I'm going to say the area of sector, AOS, area of sector, GPH. Oops, that's not an arc. Just area of sector, GPH, equals the measure of arc, GH, over 360 times pi r squared. All right, well, what is the measure of arc, GH? 72 over 360 times pi times our radius, which is 15 squared. Okay, so first thing we could do, we could try to reduce that fraction. We're just going to reduce this like we did before, okay? And maybe you'd rather just reduce the fraction first before you do anything else. So what goes into both 72 and 360? Anything? 9. 9 goes into 72 and 360. 9 goes into 72 8 times. 9 goes into 360 how many times? 40 times. Excellent. Well, hey, I can reduce that again. Because I know that what goes into both 8 and 40? 8. 8 goes into 40 how many times? Okay, so rewriting, I have 1/5 times, by the way, while we're at it, what's 15 squared? Times 225 pi. Okay, well, just like we've been doing before, and we could have done this from the beginning if you wanted to, but I want to multiply this like they're two fractions, because really they are. Okay, so I have 225 pi over 5. And wouldn't you know it, the 5 goes into 225 how many times? 45 times. And so the area of sector GPH is 45 pi square centimeters. Questions on that? Again, it's area of a circle, which you all told me, yep, we can do that. And then it's just the same as arc length, where it's some fraction of that area. You're just multiplying the area times a fraction. Okay? So why don't we try this second example here? Why don't you guys give that one a shot? Ready, set, go. Okay, let's take a look at what we have. Double check your work. So our area is going to equal the measure of the arc over 360 times pi r squared. Plugging in what we know. The measure of our arc is going to be 75. Since this central angle is 75, the measure of our arc is 75. And so 75 over 360 times pi times our radius squared. Well, what is 9 squared? 81. We know that. All right. So I'm going to go ahead and rewrite this as one big fraction, just like we've done before. And so my area is now going to be 75 times pi times 81 all over 360. I've got to reduce that down. I do not want decimals in my answer. Okay? And so I've got to decide, well, looking here, 75 ends in a 5 and 360 ends in a 0, so I know that 5 goes into both of those. I know that 9 goes into 36, and I know that 9 goes into 81, so I can reduce those. We're all probably going to go about this a little bit differently as far as what we reduce first. But we just got to remember, we're taking a number from the top and canceling it with the number from the bottom. And so if I choose to take a 5 out, 5 goes into 75 15 times, canceling a 5. And then 5 goes into 360 72 times, canceling a 5 from top and bottom. All right, well, let's see. 72 and 81. Hey, I know that 9 goes into both of those. All right, 9 goes into 81 9 times. 9 goes into 72 8 times. Okay, so now I have 15 on top and a 9 on top and an 8 on the bottom. Is there anything that cancels there? No, you should be saying no, because 15 is 3 times 5. 3 and 5 don't go into 8. 9 is 3 times 3, again, doesn't go into 8. And so what we need to do then is we need to take 15 times 9, which is 135, pi, and that is over 8, and this is square inches. There's our area. Questions? All right, so let's go to the backside. So we have talked about the area of a circle. We've talked about the area of a sector, which is a slice of pizza. Now what we're going to do is talk about the area of what's called a segment of a circle. A segment of a circle. And so a segment of a circle looks like that. This part up here, segment of a circle. Now, I guess I don't know how to describe it. It's not quite a thumbnail type scenario. If anybody's ever seen a diagram of an eyeball sideways, it's kind of the iris of the eyeball part when you look at it sideways. But anyways, that's a segment of a circle. Now, what is it made of? It is made of the area of an entire sector minus the area of this triangle. That's how you make the segment of a circle. You take the area of an entire sector and you subtract out the triangle part we don't want, which gives us then the area of the segment. Okay? So, any questions on what a segment of a circle actually is? All right, so then right there, that diagram tells you exactly how to find the area of a segment. The issue is, in this class, we have not yet talked about the area of triangles. I know you've done it, but we haven't talked about it in here. And so what I want to quickly do is add to your notes here a little bit. The area of a triangle. Anybody happen to remember that formula off the top of your head? There it is. There it is. The area of a triangle is 1/2 times the base times the height. Okay? 1/2 times the base times the height. And please remember that base and height are always going to be perpendicular to each other. They're always going to be 90 degrees to each other. So for example, if I have a triangle like this, if I want to call this part my base, that means going perpendicular to that part right there must be my height. If I have a right triangle, right triangles are really nice because then I can call this my base and this side of the triangle is then my height because it's perpendicular to each other. All right? Okay, so let's try a problem. Let's try a problem. Let's see. Do I have a good problem? Yeah, let's do this one. We're only going to do one, and then I'm going to give you guys the remaining of the time to start working on your homework. Okay? And trust me, when you're finding the area of a sector in your homework, it's going to be exactly like this problem. Okay? So please make sure you're paying close attention here. So first off, before I get going too far, I want to just think about how do I make that segment of a circle. What I do is I'm going to take the sector and I want to subtract out the triangle, which is then going to give me the segment. Okay? So first off, does that make sense to everybody? So then the next step is going to be to write down the formula. Don't plug in yet. Save the plugging in for a future step, okay? Right now, let's just write down the formula. Let's get the formula on paper. So the area is going to be the area of the whole sector, which we just did a moment ago. So that's the measure of the arc over 360 times the area of the circle. So measure of the arc over 360 times the area of the circle. And I want to subtract from that the area of the triangle, which we said was 1/2 base times height. So that is going to be our equation for the area of a segment. Okay? Yes? No? Yes. With me? All right. Let's plug in. What is the measure of our arc? 90 degrees over 360 times pi times our radius they give us is 4 squared minus 1/2 times. Okay, now looking at the triangle. Now again, you might be thinking, what triangle? I'm talking about this triangle right there. So if I'm looking at that triangle, what can I use as my base? 4. Good. And so if this is my base, what's my height? Also 4, because base and height have to be perpendicular to each other. And so then this is also 4 because they're both radii of that circle, right? So my height is also going to be 4. And so now I want to start doing some reducing. And there's a couple of things I would do right off the bat. Once I have this written down, I would now go in here and say, well, I happen to know that 90 over 360 reduces down to 1/4. Okay? The more you practice these, the more you're going to just, you know that. 90 over 360 is 1/4. 180 over 360 is 1/2. Okay? Then, 4 squared, that's 16. Then 1/2 times 4, that's 2. So I would do some of that stuff first. All right? Now notice, I didn't get crazy. I didn't now all of a sudden try to take 16 divided by 4. I didn't now all of a sudden try to take 2 times 4. Okay? Leave yourself a little bit of work. If you organize your work, this stuff becomes easier. And so now, looking here, this fraction times this stuff. I can't go past the minus sign, so it's just that first fraction is 16 pi over 4 minus, well, now that I'm bringing stuff down, now I can think, okay, what is 2 times 4? Oh yeah, that's going to be 8. You with me? Okay, well, 16 over 4, what do I get? 4. 16 and 4 reduce. And so that means my final answer, because again, I want exact answers here. My final answer for the area is going to be 4 pi minus 8, and that is in meters. I cannot take 4 minus 8 because I have to multiply by pi first. PEMDAS says multiply before you subtract. Okay? So 4 pi minus 8 is the final answer. That is the exact answer. Question? We don't put meters in square. Oh, I am so sorry. That should be square meters. Yes. Thank you for catching that. Absolutely. Square meters because we're finding an area. Yes. Okay. Good save. Any other questions on this problem? I believe you've got 2 of these on your homework. Okay? All right, so let's get going on that homework.